Okay, welcome back, year 8. I hope you had a great Easter. Ate lots of chocolate, enjoyed the sun. I know I did. Hopefully, you're back ready to go, do some maths, and back into the swing of things for this remote learning. Right, I'm going to get straight in to the lesson. Now, what I want you to do, we started it last term, but what I would like you to do is to upload your work to your OneNote page each lesson, and that's really, really useful. Now, what I've done this lesson is, you'll see in Ashil's work here, it's in remote learning working, and I've created a page with today's date. It's called types of data. That's what we're going to be doing today. So what I want you to do is carry on doing the work in your exercise book as normal, but at the end of the lesson, your only homework really is going to be to either finish the classwork, but more importantly, to upload your work onto OneNote. And to do that, I'll send a link to how to do it with your phone again. But if you've got it on your computer, you insert a printout if it's a PDF, or you insert a picture if you've got a picture there, and it should look nice and neat. Now, Ashil's a really good example here of how he's uploaded his density work. So Ashil, all you would need to do is do the same, but make sure you upload it to the correct page. Okay, it'll take a little bit of practice, but just keep going with that. It makes it so much easier to keep all your notes nice and neat. Right, great. Okay, we're going to start straight in with the lesson today, and here it is. I'm going to disappear as well. So I'm going to give you 5 minutes to have a go at the following. Can you put a title, nice margin, title, just put starter activity, and nice and neat, 5 minutes, can you answer these following questions? For the two-way table, do a quick sketch of that table and fill in the gaps. All right, 5 minutes, guys. Off you go. Okay, that's about time, guys. Right, here are the answers. You can mark your own. The first one, right, 8.45 correct to 1 decimal place, round it 8.5, so that's going to be useful for today's lesson. The coordinates of A are 2, 3, and then -1, -2. The mean, you add them all up and divide by how many there are, and there are 20 there. Two-way table, it's a bit of a logic question there. 780, 15, 3, 42, and 21. And product of primes, you may have forgotten this, it's where you split it into the factors. You circle the prime numbers like a prime tree, and then you times all the primes together. 2 times 5 times 5, or 2 times 5 squared. Okay, so take a little bit of time, pause the video if you need to mark that and make notes on that and corrections, and that's really important. Do pause it at this stage if you need to. Okay, well done. Right, okay, now back to the actual lesson, and again you might want to draw a line under what you've just done. Nice margin. Let's keep our presentations going. If you have run out of book space, the best thing is if you can try and get your parents to order you in another exercise book. That's the absolute best case. But if you've got paper, that's also fine, because it's all going to be stored on your OneNote page anyway, so that doesn't matter. Right, today's date is the 22nd, and the title today is Types of Data. Types of data. Now, there are two types of data. You need to make these notes. Two types of data. You can either have qualitative data or quantitative. Forgive me if I've spelled those wrong. I think I've spelled them correctly. Right, now qualitative is sort of descriptive. So it might be something like colour. It might be something like, I don't know, favourite food. Something that is written in words. I'll say favourite food. Something that's wordy. So that's qualitative data. Now quantitative is numbers related. Numbers. And that's what we're going to focus in on today. So we're looking at quantitative data, and there are two types of quantitative data. You can either have what we call discrete data or continuous. I think I might have spelled that wrong, but continuous data. So you've got discrete data or continuous data. Now discrete data is where it has like a fixed value. Okay, so a fixed value. Now that it doesn't have to be a whole number, but it has to be something that's fixed. So it could be shoe size, because that's done in fixed, isn't it? It could be, what else could discrete data be? It might be number of eggs, something like that. Something with a specific whole number, or half if it's a shoe size, but specific things. And continuous data, this is on like what we call a sliding scale. So something like height is where you can just keep zooming in. Height, because you measure that to centimeters, but you could go even lower to millimeters, millimillimeters, micrometers. You've got weight, because that can go smaller and smaller and smaller. Time, again, can go smaller and smaller and smaller. So they're the different types of data, discrete and continuous. And one of the tasks I set you today is going to be trying to decipher what data is discrete and what data is continuous. So you're going to have to practice that later on. Okay, so that's the notes. Now, what we're going to focus in on today, though, is continuous data specifically. Okay, continuous data. Now, continuous data is on a sliding scale. You can never measure it. You can never measure something perfectly. Okay, or it's very difficult to. In fact, I'm not going to put never. I'm just going to put difficult, actually. Difficult to measure something perfectly. Okay, now I'll give you an example. So example, e.g. I measure my desk is 118 millimeters. Okay, 118 millimeters. Now, my ruler is only correct. I can only really zoom in to the nearest millimeter. So that's to the nearest millimeter. To the nearest millimeter. Okay, now that means there is a range of possibilities of how long my desk could actually be. Because if I'm only measuring it to the nearest millimeter, well, I'm only measuring millimeters, so the next possible measurement I could have is 119, and the previous measurement would be 117. Now that means that my possible desk will range between 117.5, it's a bit like rounding really, and the top value, well, it'll be anything less than 118.5. So I've got a range of values there that I could have for my desk. That's the problem with continuous data. Now I could show this on a number line. So my desk here would be somewhere between 118.5 and 117.5. Now you've got to remember now it's because if it was 118.5, then you would have measured it as 119, wouldn't you? So when you're drawing a number line, remember that is not coloured in. But 117.5, that is coloured in, because if that would round up to 118. So you can write it as a number line, or you can write this as an inequality. And as an inequality, let's say let's put the desk in the middle. Now the desk is either less than 118.5 millimeters, or it is greater than 117.5. It will, in reality, the true measurement of that desk will lie somewhere between 117.5 and 118.5. Okay, so that's your first example. Let's look at a different example, e.g. 2. Okay, now I measure my garden, sadly this is not true, I don't have a big garden, to be 150 meters long to the nearest 5 meters. Now I might only have a tape measure, or I might be pacing this out, so I can't be too accurate. So maybe I can only measure it really within nearest 5 meters. Now write down a number line showing the range of lengths the garden could be. Okay, that could be a question, part A, and part B might be write down the inequality for the length of the garden. Okay, so a little bit of writing there, sorry, there's a bit of writing for some of these examples today. But I measure my garden to be 150 meters long to the nearest 5 meters. So how you would answer this question? 150 meters in the middle, you're measuring it to the nearest 5 meters, so your next possible measurement would be 155. The previous possible measurement would be 145. Now that means that the biggest it could possibly be was anything less than 152.5, and the smallest it could be would be 147.5. Okay, it's a bit like rounding to the nearest 5. That's exactly what we're doing here. Now on the number line, once we've got that, it's quite straightforward. The biggest it could be is 152.5. Remember to put that as a clear circle. And the smallest it could be is 147.5. And remember that is coloured in. And that would be our number line there. Okay, and the inequality, this time, again, once you've got the inequality, so let's put garden in the middle. It's going to be less than 152.5. It's somewhere between 152.5 meters and 147.5 meters. If only I had a garden that big. But the garden will range, because I can never measure something perfectly. So for continuous data, I usually have to give it a range like I've just done there for the garden. Okay. Right, your final example is more mathematical, but it works in exactly the same way. So 10.4 is measured to the nearest 1 decimal place. Okay, write down now the error interval. That's a different way of writing inequality. Error interval means inequality. For now, I'm actually going to say x equals 10.4 and is measured to the nearest 1 decimal place. Write down the error interval for x. Okay, so it's measured to the nearest 1 decimal place. That means my next possible answer could be 10.5, and then the previous one would be 10.3. That means the smallest it can be is 10.35. The biggest that could be is 10.45. So my error interval, well, it's anything less than 10.45, and it's everything bigger than and equal to 10.35, and that is what we would call the error interval for that number. That number in reality, 10.4 in reality, lies somewhere between 10.35 and 10.45. Okay, so what you're doing here is sort of a reverse of rounding. You're working backwards to just give an indication of what possible values that could be, and that is really, really useful in real life, because sometimes they will put on a sort of can of beans, they'll say this weighs 100 grams to the nearest 5 grams, because in reality you can't measure it perfectly, so they give themselves a little bit of leeway. Okay, right, what I want you to do, there is a bit of writing today to get those examples down, so I apologise, but you do need to copy those examples down, and then you've got 2 tasks to do today. So task 1, I've set you a Hegarty task on types of data. So Hegarty task 393. Okay, so that's the task I want you to do. There isn't really many workings here. You just need to write but you do need to write the answers in your book, so I can see you've done it. Write answers in book. There's no real working needed, but that won't take you very long because that's a very short task. So question 2. Now, the Hegarty tasks are not that good for this activity, so I'm going to go back to the textbook. It's going to be page 306, exercise 15B, and I want you to do all the questions. Okay, you do not need to write the question out, but I do want you to write down exactly what it says. So some of them it asks you for an error interval, sometimes it asks you for a number line. You need to be careful what it asks you to do. And then I do want you to mark your own work. This is really important. I'll put the answers on Show My Homework. Mark own work and upload to the correct OneNote page. That's really important as well. Okay. Right, I will be on my email if you've got any issues today. But good luck. Hopefully today's been okay. And we'll be back in the swing of it in no time at all. But well done over Easter. I can see a lot of you have completed most of the Hegarty tasks. They will still be on your page because you need to, if you haven't finished them all yet, you will need to get through them before the end of this half term. So if you haven't completed them, you will need to do it, and that might be some additional work you could be doing this week just to get up to speed. But if not, I'll check in with you on Monday, guys. Well done.